Okay, so for the first one, it's a rectangle. And we've actually used that formula before when solving word problems. The perimeter is 2 times the length plus 2 times the width. Or we could just add up the sides, where a perimeter is just the distance around an object. So if we added up all the sides, that gives us the perimeter as well. So it'd be 12 plus 25. You have to remember that the opposite side is the same length, so plus another 12, plus another 25. Either way, that adds up to 74 feet. For number 2 over here, that's a parallelogram, but it would actually have the same formula, 2 times 10 plus 2 times 6. Or, again, we could just add them up. 10 plus 6 plus 10 plus 6, which would give us 32 inches. For number 3, it looks like we're missing information, but we're really not. We have that this side is 12, and this side is 16. It looks like we don't know this side, but we do because it's a right triangle. How do we find that side? A squared plus B squared equals C squared. If we do that, we end up getting that this is 20 feet. So we add those up. 12 plus 16 plus 20 is 48 feet. Any questions? So our next step is to start looking at circles. We've talked about circles. Well, that looks really good. Circles a little bit. Some features of circles we should know. Pretend that looks like a circle. The main feature of a circle is a radius. The radius is the distance from the center of the circle, that would be the center right there, to the edge of the circle, to the surface of the circle. In fact, a circle is completely defined by the location of its center and its radius. Because once you know the center, every point on the circle is that same distance away from the center. Now there's another feature that a lot of people aren't familiar with that's very important, called a chord. A chord is just a line segment that has its endpoints on the circle. Or it could be a line segment that connects 2 points on the circle. There's a very special type of chord that contains the center of the circle, and that is called a diameter. If you look at the diameter and the radius, if you look at the diameter here compared to the radius, there's a radius going this way, and there's a second radius going that way. So that tells us is that the diameter is equal to 2 times the radius. It takes 2 radii to make 1 diameter. So those are the most basic features of a circle. A little bit more complex, the distance around the outside of a circle, or the perimeter of the circle, is what we call the circumference. To circum means to surround. Circumnavigate would be to go circumnavigate the globe is to go all the way around the world. So it means to go around. Circumference is the distance around the circle. About 2,500 years ago, they discovered that there was a constant ratio between the diameter and the circumference. So the ratio of the circumference to the diameter was the same for every circle. That number, however, was a really ugly number. 3.1415926, blah, 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 right? Goes on forever. What do we call that number? Pi. Pi is the ratio between the circumference and the diameter. Now, it's not very often that we know the circumference and the diameter, and we're going to divide them to find pi. More often, we know one or the other, and we're trying to find it. More specifically, usually we know the diameter, and we're trying to find the circumference. So if I multiply both sides of this equation by d to get the circumference by itself, I get that the circumference is pi times the diameter. So if I have a circle, it has a diameter of 10 feet, the circumference is going to be pi. Well, remember, pi is 3.14 is what we're going to use. Now, a lot of your calculators might have a pi button on them as well. If you want to use that, that's fine. In my math lab, it'll tell you what to use for pi. It'll say 3.14 or maybe 3.1416. Or it might say 22 over 7 as a fraction is sometimes used for pi. 22 divided by 7 is 3.1428. So it's not quite equal, but it's close. So we're going to use 3.14 unless I tell you otherwise, times 10 feet. So that's going to be 31.4 feet is that circumference. So for this circle, if I want to find the circumference, it's going to be pi, or 3.14. Is it going to be times 4? Say no. It'd be 8. Where'd the 8 come from? You have it right. The diameter is okay, it's twice the radius. Perfect. We don't need the radius to find the circumference. We need the diameter to find the circumference. The diameter will be twice the radius. So pi times 8, otherwise known as 25.12 inches. Now we could use the radius, since the circumference is pi times the diameter, and we know that the diameter is 2 times the radius, right? So it's pi times 2 times the radius, or quite often written as 2 times pi times the radius, like that. We can find the circumference like that. It would give us the same result. We would have just done 2 times 3.14 times 4. That gives us the same thing, 25.12. So in your notes, find the circumference for that circle. So the circumference is going to be what? Pi times 12, or 2 times pi times 12. And that comes out to be 3.14 times 12, 37.68 feet. How many of you came up with that? Okay. I realize I just gave you the exact same radius. What if I wanted to find the distance around half the circle? that'll be pi times just the 6, right? Why can I do that? Well, because it would be 2 times pi times radius would be the whole circle, the circumference. I want half the circumference. So dividing that by 2, you just cancel out the 2. So pi times radius. The reason I'm pointing that out is the next thing we're going to talk about is the area of a circle. And most of you know that the formula for the area of a circle is what? Pi times radius squared. So what we want to look at is where does that come from? Let's say we have a circle and we know its radius. We're just going to call the radius r. What we're going to do is we're going to cut that circle in half. And we're going to cut that half a circle into the thinnest little pi wedges we can cut. All the way through the circle. Now we're going to take those pi wedges and we're going to fan them out. Pretend these are all the same size, uniform and even and pretty, and but I don't suck at drawing for a few minutes. I know I'm asking a lot of you there. So I fan them all out like that. This distance across here, if I cut them thin enough, is just equal to halfway around the circle, right? That's pi times the radius, half the circumference. Now what I'm going to do is I'm going to take the other half a circle, I'm going to cut it in equally thin wedges. And if I fan those out, they should actually fit perfectly into the gaps here. Like that. Well, what's this distance here? That's just the radius of the circle, isn't it? So what I have formed here is, if I cut those thin enough, is basically a rectangle that is pi times r in length and r in width. If I multiply those together, I get pi times r squared. That's basically the way calculus works. Now, that's a very simplistic approach to it, but you cut stuff into small enough pieces, you can use it, you can approximate a rectangle with it. And that's finding the area by cutting into such small pieces, you can turn it into approximately a rectangle. For our purposes, we just need to know this formula. Area equals pi times radius squared. So for this circle here, if this is 7 inches, find the area. So what am I going to do to find it? It's going to be pi 3.14 times what? 7 squared. $153.86. How many of you put units on it? What unit should go on it? Inches squared. Perfect. How about this one? Find the area of that one quick. So it's pi, or 3.14 times r squared. What's my r? Careful. 5. You gotta cut it in half. It's 78.5 square feet. I have to try to trick you every now and then. Well, what if it's not a full circle? Here's a half circle. The distance across here is 8 inches. I asked you to find the area. It's going to be pi, or 3.14 times what? Is it going to be 8 squared? No, it's going to be 4 squared, because 8 is the diameter, 4 would be the radius. But what else are we going to have to do to that? It's half a circle. We're going to have to divide it by 2. So pi times 4 squared is 50.24. Divided by 2 is 25.12. That's inches squared. Simple enough, right? In your notes, I want you to find the perimeter for me. So we would look at the circumference, which is pi times diameter. So 3.14 times 8 divided by 2, which is 12.56 inches. How many of you came up with that for your answer? What do I still have to do? That would give me this distance here. To get the full perimeter, I'd have to add in that 8 inches across the diameter. So the full perimeter of that would be 20.56 inches. Now we can find areas of shapes that are not just simply rectangles, triangles, or parts of circles. We can find areas of shapes that are combinations of that. We'll start out with something here that's just combinations of rectangles. There are 2 different approaches we can take to something like this. Let me get some distances in here. We'll call this 4 feet and 14 feet, like that. One way I could go about doing this, I'll call it method 1, is adding together smaller pieces. To do that, I have to cut this into smaller pieces. So I could either cut it this way to make 2 rectangles, or I can cut it this way to make 2 rectangles. It doesn't matter which. Anybody have a preference whether I cut it vertically like this or horizontally? Vertically? Okay. So we'll leave it like this. Now we have to find out the size of each of these rectangles. Well, this one here is 20 feet here, but I have to find this side, this length here. How do I find that length? Perfect. It's 26 all the way across. If I come back 14, 26 minus 14 leaves me with 12 feet. So 12 plus 14 out to 26. That works. So that one, I'm going to call that one rectangle 1 is 20 feet by 12 feet. That multiplies up to be 240 square feet. The second rectangle here is 14 feet here. We need to know this dimension. How are we going to find that one? Perfect. It's 20 all the way up, 4 feet back here, so this is going to be 20 minus 4, or 16 feet. 16 plus 4 equals 20. So that adds up. So I'll call that rectangle 2. That one's going to be 16 feet by 14 feet. Or what is that, 224 feet squared? Does that work out? Okay. So we add that up. That is 464 square feet is the area of that. So that's the first method we could try, is adding up smaller pieces, cutting into smaller pieces and adding them up. The second method I'll call method 2, is to subtract. So in order to do that, what I have to do is I have to make these larger pieces. So what I mean by that is this. I'm going to expand this out like that. So now what I have is a large rectangle that's 20 feet by 26 feet. It would multiply up to be 520 square feet. But it's missing this little rectangle in the corner here. That rectangle is 14 feet by 4 feet, which is 56 square feet. So I subtract that piece out, and I am at 464 square feet. I get the same area either way. Now in this figure, it's about the same amount of work to do it either way. Really makes no difference. That we get the same area for both methods. But again, for this figure, we could do it either way. It's about the same amount of work. But there are some figures we'll run into that have to be done one way or another. Pretend that looks like a half circle. So if I want to find the area of this, I can't make it a big figure and subtract back out. The only way I can go about this is to cut it into smaller pieces and add them up. If I cut it across here, I now have a rectangle and a half a circle. What do I do to find the area of section 1 there, the rectangle? It's 25 inches times 12 inches, otherwise known as 300 inches squared, square inches. How about section 2? Pi times your 6 squared, and since it's half of a circle, it's divided by 2. So 3.14 is what we'll use for pi, times 6 squared divided by 2, 56.52. Inches squared. That adds up to give us 356.52 inches squared is our total area. The other side of that is we can run into things like this. Pretend that looks like a half circle. To find the area of this, the only way I can do it is to find the area of this big rectangle and subtract out that quarter circle. To find the area of the big rectangle, it's going to be 20 by, what's this distance? 16 only goes to there. I need to know this distance from here over to here. Well, what's this distance from here to here? Well, it's the radius of that quarter circle. That radius is going to be the same in both directions, right? So what's this distance have to be? 12. Very good. 20 here minus 8 leaves us with 12. So if it's 12 there, it has to be 12 here. So that makes that 16 plus 12 is 28 feet. So that large rectangle is 20 feet by 28 feet, which is 560 square feet. My quarter circle is pi times 12 squared. That is the radius. It goes from the center out. But I'm going to divide it by 4 because it's only a quarter circle, which is going to give us, what, 113.04? I'll do it out just to 3.14 times 12 squared divided by 4. Yes, 113.04. So we subtract that, we get 446.96 square feet is our area. What do you think? Any questions? 2 more examples and then I'll let you guys go. This one always tends to stump people. It's a lot simpler than it looks at first. Pretend those are both round. We have a circle with a diameter of 20 feet. Forms the outer boundary of a ring that is 6 feet wide. Find the area of this ring. Do I have any ideas? Yes, the diameter of the middle one would be 8. Perfect. Because you're subtracting 6 here and 6 here. Okay. That's a very good start. Think of, what if I did this? Let's say this is 8 feet by 20 feet. And I cut out a piece that's 2 feet by 5 feet. And I want to know the area of everything, this area. How would I find that area? Yep. Subtract the 2 times 5. Yeah. That's going to be square feet. So it's the same over here. I have the larger circle that has a radius of 10 feet, right? That area is pi times 10 squared, otherwise known as 314 square feet. And from that, I'm going to subtract out the smaller circle that has a radius of 4 feet. So that area is pi times 4 squared. otherwise known as 50.24 square feet. I subtract, it gives me 263.76 square feet. Not so bad. Okay, with that in mind, better than that. Screw it, I'm gonna cheat. Okay, so here's what we have. This is a mass, did you say? Oh, yeah, it kind of does. 200 feet by 80 feet here. And this is, oh, let's say it's 25 feet wide. I want to find the area of this. Basically, it's a track. So you're saying from here to here is 30? Perfect. You're subtracting 25 here and 25 here. Perfect. I'm going to cut it like that as well. So what I have here, I have two rectangles, right? I need to know the distance from here to here. What's that distance going to be? Well, if this is 80, right? That's my diameter from here to here. What's the radius of the circle? 40. So that means from here to here is 40 feet. From here to here is also 40 feet, which makes this 120 feet. Does that make sense? Whenever you have a circle, your radius goes in every direction. So if you know the diameter or radius in one direction, you know the radius in the other directions as well. So the area of piece 1 is 120 feet here, or here I guess I should say, by 25 feet, otherwise known as, what is that, 3,000 square feet? Does that work out? I believe so. Piece 2 is the exact same size, another 3,000 square feet. Now what I need to do is find these pieces out here. But if I look at them closely, let's see, blue I haven't used, that'll work. If I take that piece and this piece and I move them, I get what we just worked on. This outer diameter is 80 feet. You already said the inner diameter was 30 feet. So the radius of the big circle is 40 feet, or half the 80. So that area is pi times 40 squared, 1,256 square feet, correct? No, it's not. 5,024 square feet, I believe is better. Is that right? Yep. The little circle has a radius of 15 feet, half the 30. So that area is pi times 15 squared. $706.5 square feet. So I do have to subtract that. That's going to give me 4,317.5. Is that correct? Square feet? 5,024 minus 706.5. So that gets added up here. 4,317.5 square feet. So this gives me a total of 10,317.5 square feet is the total area of this. Not so bad. If I wanted to do perimeter, by the way, it'd be pretty simple. Perimeter is just going to be 120 here plus 120 here. Plus, these two distances here are just going to be the circumference of this big circle. That circumference is just going to be pi times 80, which is going to be 251.2 feet. So that's going to add up to 491.2 feet would be the perimeter. Okay, you guys have suffered enough for one night. There is a new quiz. It is due tomorrow, Wednesday, at 11:59 p.m. There's a new homework due for Thursday. Only about 4 or 5 people finished the quiz that was due last Wednesday. So if you are one of the ones that did not, make sure you send me a message so I can reopen that for you. Also, there's 2 things you need to be doing as we come to the end of the semester. If you have any late quizzes, and by late quizzes I mean quizzes that either you have not done yet, let me know so I can reopen those for you, or if you have late quizzes that I already reopened for you and you've completed them, make sure you are checking in Blackboard to see if there is a grade for that quiz. If not, let me know, because it's to transfer stuff from my math lab to Blackboard, I actually have to look through the grade book and see. It doesn't show me when you guys have done a new quiz. So if you've done a makeup quiz or a late quiz, go back and look and see if I've transferred it to Blackboard. If I haven't, let me know so that I can do that for you to make sure Blackboard is updated. I just sent out a message earlier today. If you do not have at least a total of 399 points so far for the course, you are not at a C or above. So for the course so far, your total should be 399 or more at this point. So look into that. If not, of course, you got quizzes to make up, test corrections you can do. So I've only got 3 weeks left from today. Okay, have a good night.